What's happening, dogs? Mr. Allen here with some sketching of polynomial functions, giving a description of that polynomial function, some characteristics about it. So for the first one here, we have a cubic function. It's got one real zero. That means it's going to cross the x-axis once, and a negative lead coefficient. All right, so if I have myself a graph here, it's got to end going down and to the right, but I can only cross the x-axis once because it is one real zero. So I'm going to do something like this guy right here. Pass through. Whoop. Beautiful. Fantastic. Excellent. You also could have, there's another possibility here. We could have started maybe, up here and crossed over at that point in time as well. So wherever you want that graph, that's cool. This right here and here, these are my y-intercepts of these two different examples, right? That's not a solution. That's not a real zero. The real zero is right here or right here, okay? And there's only one of them. That means we have two imaginary solutions here for this one. All right, next example, we got a quartic function, okay? So it's gonna be a W or an M shape. It is a zero with a multiplicity of 2. That means it's gonna bounce off the x-axis, a positive lead coefficient, so we're talking a W shape for this one, and two imaginary zeros, meaning it's not going to pass back through the x-axis. Okay, so I think we really have like one or two possibilities of how we can graph this thing here. We said it's positive, right? So it's going to come down, bounce off, and then come right back up. That's one way of graphing this thing. You also could have had it, the other one here, wee, boop. If that were to have touched the x-axis, make sure it looks like it touches that, or even put a point there to make sure that it's very clear. You're like, hey, I'm bouncing there, bro. All right, there we go. So I've got two imaginary zeros. If this part wasn't here, right, the two imaginary zeros, we could have come back down and through it, right? Because we still would have had a zero with a multiplicity of 2. We would have just had a little more freedom as to what we wanted to do there. But because it said two imaginary zeros, we knew we could not cross back over that thing. All right, next one here, quartic function. Again, a W or an M. Two real zeros, and I've got some information about end behavior here. As I go to the left, I should be going down. Well, this tells me it's a negative quartic then, because my end behavior has to be negative on both sides for this particular one. All right, so it's going to be flipped from the last one we just did here. So we've got, let's see, we got two real zeros, okay? So I think that would really imply then two imaginary zeros. We could have also had said that there. It would have been kind of nice. But for this one here, I can just come up, woo, boom. As x approaches negative infinity, f of x approaches negative infinity. So that works. You also could have it, flip-flopped and done like something like this, right? That works too. And if we, honestly, because it doesn't say that the other two have to be imaginary zeros, you really could have, had a few different options. You could have gone through it 4 times if you really wanted, but I guess because it says two real zeros, it's implying that's it. There's actually another scenario here we could have done, isn't there? Could I have, I'll make this will be really tiny now. Could I have bounced? That's still two real zeros, technically, right? They're not unique, but it's still two real zeros. So that pink one there, or making the bounce over here, would have also worked for this one, okay? So again, there is a little bit of freedom in this one, which makes it kind of confusing when you're trying to do these problems and check them on homework. You're like, am I right? Are you sure? Because mine's a little bit different. So I get where that confusion can come in here. So hopefully this is helping solidify it. Last one, cubic function, 0 with a multiplicity of 2. So we got a 0. It's gonna have to bounce off that one. It's cubic. All right, and as I go to the right, I'm going up, right? As x approaches infinity, f of x approaches positive infinity as well. So I'm going to end going up. So it's going to be the flip of this original one that we had here. And since I have a 0 with a multiplicity of 2, I've got a couple ways to draw this. I can bounce off first and then finish going up. So I'm really going to have 3 zeros here, 3 real zeros, 2 unique ones. One bounces, the other one has to pass through. There's no way of making this happen if I don't pass through for the third one right there. All right, so that's one option. The other here would be kind of like what we've been doing. I could come up through this and then bounce on the second one as well. So either one of those would work there. My end behavior matches up. As I go to the right, I'm going up. It's a cubic function. It has a 0 with a multiplicity of 2 right here, and that would be only a multiplicity of 1. All right, you guys, so there we go. Sketching some polynomial functions, giving a description of those polynomial functions and the characteristics about them, lead coefficients, end behavior, all that good stuff here, man. That's dope. That's super dope. You guys are super dope. Have a great day.